This video is an excerpt from the ϕPPL Programming Language Lecture Series. Copyright 2013, Technoventure Incorporated. Logical Boolean Operators. In an earlier tutorial, I covered the subject of bitwise Boolean operators. If you have not yet seen that lecture, you should watch it before this one, as it contains basic information that is assumed in this session. The logical Boolean operators are very similar because they use the same truth tables that we discussed in that session. However, the logical operators work a little differently, and those differences easily justify their existence. Both kinds of Boolean operators work basically the same in C and phi. There are only a few minor differences between the two programming languages in this area. The rule that is used to write a binary logical Boolean operator is the same in C and phi. The AND, OR, and XOR logical operators are made by doubling the bitwise symbol. Phi extends this rule to the unary Boolean operators that were introduced in the lecture on the bitwise Boolean operators. In a way, this rule is counterintuitive because bitwise operations are plural since they are multi-bit operations done in parallel. Many people write two symbols together to mean plural, such as $, which means dollars plural. Logical Boolean operators only work on a single result at a time. I would venture to guess that Dennis Ritchie experienced the bitwise Boolean operators to be used more frequently than the logical Boolean operators, so he chose to make it easier to write them as well as take up less space. Also, expressions that construct integers using a lot of bitwise operations are frequently very long and complex, and the space savings is welcome. C provides one, and phi provides two additional unary logical Boolean operators, each of which is composed of a single character. But the symbols used are different between the two languages. For those who prefer compatibility with common mathematical notation, phi recognizes a single Unicode logical not symbol. As in C, this symbol precedes its operator instead of following it. The is operator was created for the phi programming language to act as the logical same operator. It looks like an inverted not symbol. This behaves in similar fashion to the not operator, except that it uses the identity truth table. As we look at this table listing all of the Boolean operators in both programming languages, we notice that the logical not operator in C is a single exclamation point and not a doubled tilde. The doubled tilde is an even part of the C language. Also, there is no is operator in C. In phi, all of the logical operators can be created by doubling their bitwise symbols. A double complement makes a logical not, while a double same makes the logical is. So what are the differences between the bitwise and the logical Boolean operators besides the way they look? Well, there are basically three differences. First, logical operators only have single-bit operands. If an operand is not a single-bit Boolean operand, then it is implicitly converted to one with a test for not equal to 0. Both phi and C behave this way. Logical Boolean operators do not have to be strictly used in control structures. They can be used in expressions to force a result to a single-bit value, such as in this expression. This implied operation in C and phi is very useful, but novice programmers should be wary that this implied conversion is taking place. Here the result of the operation placed in A will be 1 because neither 2 nor 4 is 0. If the logical AND operator is replaced with the bitwise AND operator, then the result placed in A will be 0. Can you understand why this is? The second thing that sets the logical Boolean operators apart from their bitwise counterparts is that they have low precedence. In fact, only the left assignment operators have lower precedence. Keep in mind that the only assignment operator in C, the ASCII equal symbol, is a left assignment operator even though it does not point to the left. Operator precedence makes it possible to control default operation order without the use of parentheses. In this example, we test for the AND of two conditions producing a single Boolean result. When we place parentheses in the positions shown, it does not change the way it is computed. The third reason why the logical operators are different from their bitwise counterparts only applies to the and or operators. When these operators are used in the test clause of a control structure or any other expression, the second operand is only evaluated when necessary. The second operand for a logical AND operator is only evaluated when the first operand evaluates to 1. Likewise, the second operand of a logical OR operator is only evaluated when the first operand evaluates to 0. Both operands of the XOR operator must always be evaluated because the overall result depends on comparing both operands. In this next example, the source code for both C and phi are identical. A comparison of D with E is only computed if B is first found to be less than C.